We're back. It's a room of theater people. Everybody got quiet when you say we're back. Yeah, okay. So for this last hour 15, hour and a half, hopefully we're going to build a little bit on what we've been talking about before. I might suggest before we get started, we've got 3 really small tables. If we could sort of combine them into 2 tables or 3 tables, something like that. Perfect, okay. I mentioned at the start of this whole extravaganza yesterday that this is still a pretty nascent field. There are currently 2.5 ABET accredited programs that focus on engineering for the entertainment industry. One is here, one is at the University of Connecticut, and one is underway in the process of getting accredited at UNLV. I don't know how close they are. Yeah. Oh my gosh, that's another whole panel that I don't. But they are accredited through ABET, which is the Engineering and the Technology Accreditation nonprofit here in the United States. And there are a bunch of steps, and Purdue is right now in the middle of its 5-year review of all of the engineering programs, and so it comes as a big chunk. And there's something like 45 external reviewers who are on campus for a week this September. They're going to talk to all the faculty. They're going to look at all the classes. They're going to pull capstone projects and ensure that those capstone projects meet the expectations. So there is a fairly large threshold to cross. And at Purdue, I say this only because I'm pretty sure that one of Lee's capstone project will end up getting pulled for this. For every program, and theater engineering is part of multidisciplinary engineering, they randomly pick 5 capstones over the last 5 years to look at. And the last 3 reviews or 2 reviews of theater and multidisciplinary engineering, the only capstones they've pulled from all of the concentrations in multidisciplinary have been theater engineering capstones, which is, it's definitely random, right? On the flip side, what they have said consistently is, why can't the rest of the capstones across engineering look as great as these? So we'll take that as a win, right? Don't say that to anybody at Purdue outside of this room, because they'll get mad. But it's still a pretty nascent field, right? We've had a theater engineering concentration since 2017. UConn started theirs in 2020. UNLV has had an engineering entertainment design program for a long time, but it's not accredited yet. Is very close. Point Park University is about to try to launch a program. And I know our friends from Spain are on their way. You just came from there. No, you're on your way there. Yes. Tomorrow, yeah. And other schools have asked about it. But it's still a field that doesn't have a clear and consistent set of expectations and understandings about what folks should be learning. UConn is a little bit different than what Lee got when she was here. UNLV is definitely different than both of those programs. And so part of what I hope as an outcome from our conversation today is to start to establish some shared thoughts about what are some important learning outcomes for students in that interdisciplinary space of engineering and entertainment. And ours is very focused on physical elements, so structural, mechanical, but we've also had an acoustical engineering concentration at Purdue. There is always the possibility for a lighting engineering concentration, so we can think a little bigger than that. But I hope that this will build on the conversation that we started earlier about what do people need to know to be successful. And so I'm going to walk us through a couple of things. How many of you of my academic friends have dealt with learning outcomes? How much do you love it? You love them? Megan is my new best friend. Thank you. They're frustrating, right? And the way that they're used in academia is frustrating, and the way that academic units often encourage faculty to think about them can be frustrating. And so if you're frustrated by it before we even start, I apologize. But we are going to talk a little bit about the idea of learning outcomes and programming outcomes. I got a couple of things I'm going to say, and then we're going to do some work together. Does that sound like a plan? Anybody want to leave? Okay, good. Some questions to sort of frame this here. How can we keep up with training of students as knowledge and technology continues to evolve? We were just struggling with that question. Some things that are worth keeping in mind. Costs limit the ability to upgrade our infrastructure on a regular basis. So as an example, I gave a tour to some folks earlier this week of Powell Hall, which is the Visual and Performing Arts building here on campus. It's 21 years old. It was state of the art when we moved in. It was not state of the art 2 years ago. And it took $750,000 just to update the audio and lighting systems in the 2 theaters, right? And that represented 20 years of trying to catch up. And I would say that we are mostly state of the art now, right? Like we're not cutting edge, but we're at least consistent with what you might find. It's expensive to keep up. Megan, you and I have talked many times about trying to get Navigator at Purdue. I can't afford it. I can't even afford one system for how often we would use it. And so how do we then keep up with what students need to learn? And then time limits the capability of people like me to stay up to date. The other thing that I haven't said to Megan about Navigator is I'm scared to death about having a Navigator on campus and not knowing how to use it and not knowing when I'm going to have time to use it, right? And I would love to teach Revit. I would have to learn Revit to be able to teach Revit, and I don't know when I would find the time for that. So those are 2 real big challenges in staying up to date with learning outcomes. And while we can advance research, we are super conservative. How many of you in academia have tried to propose a new course? And how long does that take? Yep. How many of you have tried to propose a new curriculum? How long does that take? Ongoing, 3 to 5 years, right? It is a very, very slow process. So making changes to the courses that are offered, the content that's offered, or the overall curriculum, it's glacial, which is tough when we've got an industry that's moving and changing rapidly. And I think that, I say that because that disconnect, that tension has to inform how we think about how we structure courses and learning outcomes in curricula. We have to be flexible, but we can't be so specific that we'd have to spend 4 years to change certain things. Does that kind of make sense? Okay. What happens then because of that is programs create the great lists of programmatic learning outcomes for their curriculum. This is from a program that shall remain unnamed, not Purdue. This is the set of overarching program outcomes that they have for all graduates of their program. Sounds good, right? Say that again. Megan's jumping to the next slide. I love it. Yes, but you've hit the nail on the head. These become so vague, right? As to, yeah. They become so vague and broad that they don't actually say anything. Like, what does it mean to graduate students who apply knowledge of their skills, of the business of the performing arts required to develop and manage? I don't even know what that means. And how is that different than a business school, right? What makes that specific to a theater program? No idea. It doesn't, right? Like it doesn't make this specific to anything. And I can make the same argument that we're doing this at Purdue, even if we don't have a business class, right, in our program. Sure, we prepare you for that, absolutely. To Megan's point, how do we measure that? How do we demonstrate that? Evan, did you have a question? You're scratching, sorry. I think a related conversation is I hear from industry folks all the time, the job skills that folks need. Matt, we've had this conversation all the time. You've told me Revit, Revit, Revit over and over again. No, not Revit. Ian's told me Revit. You've told me Inventor over and over and over again, right? Or SolidWorks. Like they need to know Inventor. They need to know AutoCAD. They need to know SolidWorks. Those are still really broad. Like what does it mean to know Inventor? What does it mean to know Inventor?
It means that it means like riding a bike, right?
Okay.
I don't need an expert in Inventor. Waste of my time. I need them to be able to navigate inside the program, whatever, Revit, right? Understand how it works, how it considers objects, how it generates objects. I don't need you to do a super fancy object for me because I might not need the super fancy. But I need you to know how to do it.
I need you to know how to generate objects in Inventor. Like that's a specific.
It's specific and it's measurable, right? You have your hand up.
Yeah, and I mean, I think the crux of this, and you're probably already there, is we need people to be able to, sorry, I just completely lost my train of thought. Let's get it back to you.
You shouldn't have cracked your knuckle. That's the thing. It popped a bubble in your brain. So if we do this well, if we can create learning outcomes as opposed to listing job skills or programmatic outcomes that are measurable, or a thing that I can say, this is good at it, and this is not so good at it, and this is like really poor at it. And also think about those outcomes in terms of types of learning. How many folks are familiar with Bloom's taxonomy? We talked about this the other day. We are now. I only talked a little bit of it. I guess I deserve that. You're so good at it. Do you want to tell us? Not at all. You see, that's how that works in my class too. Does anybody want to share Bloom's taxonomy? Just a quick overview. Look at how quickly you all get quiet. Oh my God, it's just like my classes.
Pyramid with foundational skills, and then as you graduate towards the top of the pyramid, it's like actualized. Being able to take all that foundation and apply it into a practical sense.
It,
Maslow's
hierarchy of needs. It is related to Maslow, or it feels like the hierarchy of needs. I think the thing I would say about Bloom's taxonomy, we're going to look at the diagram in a minute, is it categorizes skills into types of knowledge, right? And some types of knowledge are things like, I know that inventor is a thing. And I can tell you, you can buy it from Autodesk, and it's going to cost this amount of money. I can recall that information. Or I can use Inventor on the other end of the spectrum to create a robust set of designs and drawings for a project, right? That's sort of the spectrum. But so thinking about the outcomes we want students to be at in terms of that taxonomy is really important. That's why I asked, what does it mean to know Inventor? You didn't talk about using Inventor at any of the highest levels of Bloom's taxonomy. You were down what we'd find is about the bottom third, which is great because it helps us decide what to list as an outcome. The other piece is, and they're kind of related and some folks conflate them and I like to pull them apart, is there's also levels of competence. Are you a novice at using Inventor to move around, or are you really, really proficient at it, right? And so thinking about all of the skills, where they live on that taxonomy scale, and your level of proficiency, and how to measure it, thank you, Megan, are the key things to think about. So what I would love to do today is to spend some time thinking about that. There we go, a novice to expert and remembering to creating. So let's take 10, 15 minutes in our tables. Identify one, just one skill, idea, thing, topic that you think students coming out of an engineering and entertainment program should have. And we'll keep it that vague. Yeah? Argue about it until you come up with one for each table. That's essential. Anybody coming out of a theater program and engineering program together should have.
Undergrad.
Undergrad, yep. Talk amongst yourselves.
Can I play devil's advocate?
Yeah, please. Yeah. Please.
We have done research with some colleagues, not in theater engineering, but in engineering. And we found out something interesting. It's once you evolve in your study plan, including learning outcomes,
But I think
even if you rephrase,
tying
you
into some
reshape learning
technical
outcomes,
design capability too.
courses remain the same.
That's,
So
You
Yep.
will go afterwards.
Mhm.
I think
Okay. I don't want to say it out loud.
No,
because
that is-
maybe I was booming your
no,
presentation.
that is exactly the point is,
And we did it with systematic research with Spain, Croatia, mainly with mathematics for engineers.
Mhm.
And it's very interesting how academia, even if we have much more freedom than high schools, because they have a very set up curriculum, we don't have that. But we have like this, we call it with our colleagues the prevailing epistemology, which is something we as teachers have. And math for the first years has to be calculus that way with these very specific themes.
you are absolutely right. And so the next steps today are going to be things like, okay, let's refine this into something that's measurable, right? Identify those. And now,
I mean, two different worlds. in Europe, we had a huge reform in 2008
Mhm.
of the higher education. That was like we moved from content-based study plans to learning outcome or competence-based study plans, and we analyzed how the exams were pre and post reform, mainly mathematics, but also in engineering courses. And it was quite funny because the exams were not even the same, but even more algorithmic, more technique based, and it was like shocking.
Interesting.
Just the opposite.
Interesting.
The reform wanted or was intended to
That's fantastic.
promote.
That's fascinating.
We have some research on mathematics, but
Yeah.
I think that it's not something specific for mathematics. But
Well, I think you identify the problem, right? Is going from this to what's happening in the class. And so part of what I hope we'll talk about today is, okay, that's great that we've identified this, but like, what's the learning exercise?
Yeah, exactly.
What are they
And
going to
the
do?
assessment is
And
also-
what is the assessment piece?
How you put that into the reality? How do you assess that? And even if you are able as a teacher to overcome what the core has been till now, because you have maybe taught that for 50 years, and that's leading to something different.
Yes.
And I think this prevailing epistemology is very strong.
It's hard to break.
And even if it remains very implicit, great.
Yeah, I hear you. So I was part of a process to do this kind of interrogation of the College of Technology here on campus, and it was 3 years. I saw exactly what you're describing, and it was like, oh my God, yeah. So I can't promise that we'll be successful today, but I'm hoping we'll at least address that.
That's
Yeah.
nice. Thank you.
Great. Sure. Brian has asked me to repeat the question for clarity, so I will repeat it and restate it. Spend some time amongst yourselves identifying, we want to kind of get to one skill, content, topic area that you think students should know, for lack of a better word. That's a word that we're going to interrogate here in a minute, but by the time they're done with a program that combines sort of an entertainment focus and an engineering focus. And to add to that, sort of think about categories of knowledge, things like what do students need to know, what do students need to be able to do, and how do students need to be able to think, right? The things that you're talking about might fit into one of those three buckets, or probably should fit into one of those three buckets. So ideally, you're making kind of a list together, and at the end of the next 8 minutes, pick one for us to talk about. Yeah? Does that help?
Yes.
Yeah. So, know, do, think. All right. It sounds like everybody's kind of settled on something to move forward with. Yeah? Yes? More or less? Okay. What I'd love for us to think about next, and in the context of levels of expertise and in the context of Bloom's, let's get specific about what level of mastery and sort of where and how it fits in Bloom's a student should achieve at the end of 4 years, right? So for example, not to pick on this group, but it's just the one I remember, working in a team. What level of expertise would you expect or want a graduate of a 4-year program to get to for working in a team? Do you see what I mean? And then, I'm not asking you to answer now, talk amongst yourselves, right? You had critical thinking and like troubleshooting a faulty circuit, right? Like what level of expertise, what does that mean? And that could include what is the complexity of the circuit, for example, yeah? You guys didn't actually tell me what you had settled on. What did you settled on?
I think we're going to go with the first one. Go with our gut and say
Systems
systems integration.
integration, okay. There's a lot of room to talk about expertise there. I love it. For an entertainment engineering student, systems integration. Keep it, yeah, on the target, yeah. And over here,
Yeah, we thought graduating undergrad should be capable-ish or proficient in evaluating technical requirements in order to realize the vision of a director or scenic designer.
evaluating technical requirements to realize a vision. That sounds fantastic. When you say proficient in, let's get really specific. What does that mean, right? If you say expertise at that, what does expert mean? Sort of put it in this category. Similarly, take about 5 or 10 minutes and think about what level would you expect an 18-year-old out of a typical American or European secondary school to arrive at what would be their level of expertise and or the amount of knowledge they would have in Bloom's taxonomy. Because that's going to tell us how far we got to go. What's that? Donkey. Spend about 5 or 10 minutes just sort of sussing through that. So in an ideal world, as we begin to think about coming back together, each table should be able to talk about where they expect the student to be at the end of 4 years in that particular skill set that they were talking about, using language like they should be proficient at applying X, Y, or Z, right? Or we expect them to come into the program as a novice, barely able to remember what it means to build a piece of scenery, right? So take a few minutes to make sure you sort of can say concisely what you're thinking about in those terms. And as soon as we've got a couple of people in the restroom, as soon as they're back, we'll come back together and talk together. Are we ready to share together? Can we do that? Can we start, because this is where the microphones are, with that table? Can that table in that corner, we're going to call you guys the Red Hat Club because you have a red hat. Can you share in sort of one statement your end of time, end of 4-year learning outcome?
Oh, you're talking to us?
I am.
Oh, well, I have it.
It's just like in class. I love it. You were focused. I get it. You're
So
good.
we did narrow it down for you.
I wanted you to get it.
Demonstration and application of troubleshooting processes and documentation.
Okay.
So being able to take a flow chart of the troubleshooting process and kind of putting that in your brain and having a way that when you see a problem, you don't just freeze. You actually take some steps to be able to solve it. So we said for someone coming into a program, based on experience from LT here, we're at a novice for people coming in. But leaving at least being applying and capable.
So capable to apply troubleshooting process.
Yeah, not an expert, but you
They
will
might need
take
some
some
help.
steps.
You might have to come in and say, did you think about flipping that switch before you flip that one? That kind of thing. Okay, great. What about this table over here?
For our group, after 4 years, we're hoping a student would be capable of evaluating technical requirements in order to realize the vision of a director or scenic designer.
Okay, great. So capable, again, similarly, you might have to come in and say, you know, you missed this part of the conversation that I overheard from the director, but great. We'll give this to you guys. Can you pass that microphone across to that table?
So we said our skill was working as a team, collaborating, which Rich would like us to break into many different things, and we certainly did. There are many things that contribute to being a good collaborator. We certainly identified that students coming in from K through 12 for us right now are very much they are aware that they're supposed to work on a team. Teams exist and they think they're probably good at it, but they have no idea. And they are definitely novices. And it's something that we spend 4 years in theater education cultivating how they are communicating, how are they fostering those interpersonal skills, how are they problem solving together, how do you know what your lane is, how do you know how to cross lanes and share. So leaving, we are hoping that they are applying the information they use, specifically that we've given them tools in a toolkit to use in a new situation. So every time they come onto a new team, oh, I am aware that not everybody communicates the same.
Mm-hmm.
I need to present that in different ways. And then capable of applying is basically where we sort of landed, that everything above that goes into becoming a team leader, which is an entirely different expectation and skill set,
Sure. Great.
advanced skill set.
Okay, and then over here.
So we started out talking about communication broadly, following on that, and we maybe distilled it to, we'll call it analog communication, being able to communicate ideas using drawings or writing or speaking, and digital communication, being able to have things talk to each other digitally, light boards, soundboards, this sort of stuff. Then Rich came over and said that's way too broad, so how about if you pull that back a little? So we focused in on a measurable skill, let's say a data network used for entertainment systems. lighting, a sound system, an automation system, all talking together, right? Maybe a show control system if we want to have that. So we thought by the time you left undergrad, you would be at the analyzing high level proficient, and that would look something like at the end of the class or the whatever, however you're evaluating this, you would plug these systems together. As the teacher, you would make it break.
Yep.
Without telling them.
I've done
And
this
then,
before. Yeah.
they would have to get the software tools to find out that you had made two things have the same IP address or something that would cause the whole thing to go down in flames.
Sure.
So that not just understanding how to physically connect it and configure it, but how to fix it when
Sure.
it doesn't work. So at the most basic level, and that's probably, I'm going to guess, kids coming out of high school might know that stuff because they've lived with IP addresses and Wi-Fi and all this stuff their whole life.
Just
Yeah,
I will say, just based on watching our undergraduate students try to connect the ETC dimmer DMX nodes to the network system, they don't know what an IP address
Okay,
even
they don't, all right.
means.
Got it.
Like, these are just numbers, right? I don't know what, I set these numbers to 113, is that right?
It's a Windows machine.
Oh my God. Yeah, so
That's a good
I think that's a big assumption,
Okay.
but
The novices, they don't know anything about it. Coming in cold.
yeah.
And hopefully getting to yellowish by the end.
So like the advanced proficient.
Analyzing proficient.
Okay, great. So I'm going to acknowledge, and I'm going to call Jen out a little bit. Jen, when I sat over here and said that's too broad, Jen said, for a program outcome, I don't think so at all. And to a certain degree, you're right. Right, for a program outcome, being able to work in a team is probably a legitimate way to phrase it. But I think there is a tension there with this is the program outcome, and then how do I actuate that in a class? How do I actuate that in an evaluation? That's kind of why I pushed you a little further, please.
In our program outcomes, we have subheadings.
Sure,
So I'm just saying
yeah,
that's the big one. That's one.
Sure,
That's
yeah.
A, and then there's 8.1.
I dig it.
8.2.
I dig it.
So-
No, okay, I appreciate that. So, and part of it, I will admit to a bias, right? I am in the middle of taking a very exhaustive look at our plan of study and our curriculum at Purdue for a lot of reasons. And this is the thing I keep running into, is we have these broad statements that we've talked about, and then we have all of these other classes that don't even deal with that. And Ignacy mentioned that too. Like, this is a thing that happens, right? People come up with these program outcomes, and then people just keep teaching the classes the way they teach the classes, and never the two shall meet. And so for me, thinking about some of these broader things is in smaller chunks that can be then input into, and I can say to Chris, you're the one teaching this class where this is most likely going to show up. So here is the thing, and make it fit there, right? All of which is great, and all of these are great. Now I want us to think about the next step, which is how do we assure that a student has actually achieved that? What is the experience, the deliverable, the project by which we can assess that somebody is proficient at analyzing the troubleshoot, like the system drawing? You kind of already provided one a little bit, so think about a different one maybe. Right, like, and think about what that assessment looks like. And is it pass-fail? Is it on a Likert scale of F to A, right? Like, what does that look like? Yeah? How would I assess that and measure it? Oh, everybody stopped.
It's on.
Everybody's now thinking. Sorry, yes, please, go. Yeah. I think I'm going to just leave the question open. But I think it is two pieces. Like, what is the project exercise deliverable, and then how is it being evaluated? Are you guys ready to report out what you've been talking about?
Yeah.
Totally. You've got a microphone, so there you go. That's all right. They're still talking, and we're going to call on them here in a minute too.
What was the question?
It is just like we were looking at.
Turns out people are people.
It is definitely the end of the day. Everybody's getting a little punchy. What are the assessment methods? Like, what are the exercises, the projects, the deliverables that we're going to assess, and how are we going to assess those? Like, what is the I don't want to say rubric because it gets a little too deep, but is this a pass-fail situation? Are there
We totally used rubric.
Are there
talking
great,
about ourselves.
but so there you go.
So since we're talking about teamwork, particularly in collaboration on a theater project. We are talking about the practical work of doing a production, not necessarily the classroom work of imagined designs, unrealized designs kind of thing. And we talked very specifically that for undergraduate training in particular, we have very, very detailed, like, this is your role on design meeting 1, here is your deliverable. On design meeting 2, here is your deliverable. Like, we do have that mapped out and pretty formulaic. And that may simply be because I'm producing a 9-show season in 10 months. Right? And undergraduates are actively participating in design roles as part of that. We are very good about evaluating a project at the end of the project too. It's not a year-end evaluation. There's what went well, what do we need to work on, and then the overall evaluation of the year is, of course, was progress made on the things that were coached. But we did talk about how do you measure success or failure, and it's not necessarily about the production being brilliant and perfect, whatever a perfect production is. Whether there were failures in realization, whether there were failures in an ability to find shared ground, was the teamwork to try to get there successful, is the thing that we are talking about evaluating that's going to help you have success as a career. So is that answer enough, or do you want more specific?
I think so. I kind of if I could just ask you to answer this question. Presumably in your program, students are doing productions multiple times, right?
Yep.
And part of what we've been talking about is by the end of 4 years, we want them to be capable of applying.
Yes.
Right. So is it that last production that gets assessed to tell you that they have reached that level of being capable of applying those skills? Is it a cumulative assessment of a bunch of things? Like, what does that look like? Because how do I put a stamp on Pablo at the end of 4 years and say, Ka-chunk, you are capable of applying these things, and this is how I saw it.
Again, going back, I'm going to speak from the I and from my
Yep.
program. There is evaluation after every project, after every production that you had a role on, and then there is an evaluation at the end of each year. And there have been, particularly the junior year evaluation, is where we say, you are making progress, where I could say at the end of your senior year that you can capably apply teamwork. And there have been junior evaluations where we say, you have dug into the trenches, you are not participating. I cannot give you another production assignment because you are so entrenched in your inability to teamwork. And what you really want to do is just program the light board, and that's why you're being obstinate, right? So I do think that, especially with us saying that, like, students are coming in below the purple on this skill set, we are cultivating the ability and tools to have the ability to work on a team and be a productive member of the team.
Sure.
So yeah, I think that has to be a progress report, and that has to be assessed along the way. And it's not, there are plenty of programs I know where the faculty have just been like, I'm writing that student off versus I'm giving feedback and actually trying to develop them.
Sure.
So.
I appreciate that. And I think one of the things that's interesting about this discussion right now is, how many of you are familiar with the idea of signature pedagogies? Anybody familiar with that term? It's probably about 20 years old now, but there were a couple of instructional design researchers and theoreticians who posited that there were, in some fields, pedagogical approaches that were signature to that field, that grew out of that field, they're used in that field, it's not really exist in others. Think like doing rounds as an intern, as a doctor, or doing live debates in law. Capstone project experiences are like a signature part of the engineering world, right? And that's how you get that final assessment. So I know in engineering here, you might work on some teams here and there, but you don't really get assessed on your teamwork until that, I'm looking at Khalid, until you get that capstone experience, right? That was like the first time that anybody really gave you feedback about your teamwork. Right, so we find out how you are in your first year, and then we talk about it in your fourth year. But the sort of ongoing formative analysis or a response throughout all 4 years is very signature to theater. And at this intersection of entertainment and engineering, that is an interesting challenge, because how do you combine those two signature pedagogies? And I don't know that we have done it particularly well. We've done it one way, but that becomes part of the question that this leads to, is how do we guide programs to thinking about how do you bridge that gap? Because you're not going to have in many engineering programs, at least that I've talked to in the US, a faculty member who's consistently engaged with specific students and watching their growth over 4 years, because those programs have thousands of students, right?
That's interesting. It came up, oh, you're working on projects outside of the classroom with your students, and that's something that is sort of signature to theater.
Yes.
Not only are we working, only are we observing them on those projects, we are often on the creative team with them.
Yes. So they're having to partner with people at different levels of power.
Yeah, it's a different it's a different engagement from a faculty point of view.
Yeah, and then there's another whole conversation about, are those outside the classroom projects
How healthy is that?
for course credit or not, right? So this is great. Thank you.
Good, but it's getting better.
Over there, you guys have the microphone.
So we kind of. Hello. I don't know if it's on or not. We're on. Okay. So we kind of gave this the evaluation model last time, but we decided how to parse it a little better. So we started out just saying pass fail. Did the show go on or not? Pass fail. Then we're like, well, yeah, but there might be something more to it. So we kind of came up with this scheme whereby the amount of things you broke as the instructor would be a lot of things. The Kobayashi Maru.
You can go to Kobayashi Maru.
Yeah.
You can never win.
Sure.
Can't win, but
your level would be how many things you solve.
How many Star Trek fans in the room?
Exactly.
Come on.
How many of you know the Kobayashi Maru? So
You
it's the
can't-
idea that you get in a test as the starship captain that you cannot win, right? Your ship is, whatever you do is going to be attacked, people are going to die, and that's the end, right? No matter what you do.
Not the scenario we're looking to replicate.
So whatever you do on the show, someone's going to fall from the grid. No, but that's not what we're doing. But there's no, it's the no-win test. You cannot be successful.
As an instructor, you can keep things failing as they show more proficiency. And I guess
Sure.
you could actually create problems that they only have knowledge sort of how it works. They would have to create something new in their head to figure out why this isn't talking to this.
Sure. I mean, in some ways, that is the chaos of a production in the model that Casey's talking about.
John was telling us about at USITT. There was, is it Tech Olympics? Was it?
There was a lab.
A lab where
the troubleshooting lab.
where they were
Yes.
screaming over comm that what was happening in the show while you were fixing whatever it was that was broken. A real world situation, right? So throw that into, that'd be great.
Well, I think, and as we were talking about before, whether it's too broad or too narrow, there's a lot of interesting subset skills in that. Like the fish or cut bait was how my undergraduate TD phrased it. Like, at a certain point, do I keep troubleshooting the problem, or do I say do this other solution instead? Like, what is the cutoff point, right? And also, how effective are you at keeping your cool while the stage manager is screaming in your ear that this thing needs to be fixed because we need to go on, right? Like, yeah. Are we good? Are we good? Are we good? Do we need to take a 10? That's my favorite.
How successful are you when your pants are on?
Right. Yeah. How successful are you when your pants are on fire? Yeah. How much can you still think clearly even when you're panicking? Yeah.
Can you triage a problem?
Can you triage a problem? I think how you assess each of those pieces is still an interesting question, right? Because we sort of, if I understood right, you were talking about the percentage of things that you're able to troubleshoot even while we're continuing to cascade it on you like a bunch of jerk faces. How successful, like that's one metric of success. But right, yeah. And I think that's one axis, right? And that is specifically the understanding the system design skill. Absolutely. Yeah, great. Over here.
Yeah, I mean, as a recap, our goal was to have students capable of evaluating technical requirements in order to realize the vision of a director or scenic designer. And honestly, this is like capstone written all over it, I think. We proposed kind of multiple pieces of a larger assignment, including a report, a budget, drawings showing proposed solutions, some sort of narrative, and design documents that show, the extent of the research. We also think, this is probably gets one final grade at the end, but there's progress evaluation along the way. And part of the final evaluation is, did the students incorporate progress feedback? Did they actually pick up the notes? So that's kind of what we were thinking.
Okay. I feel like I should have more response to that, but I don't. I just want to say, okay, that sounds great. Any response from any of you to that? Since I'm doing a lot of talking? All right.
No, the coachable part, can you incorporate feedback successfully? And like, can you take it, number one, especially if it's constructive, can you take it and then can you successfully incorporate it? Like, that's a huge thing. Like, I train managers all the time, like how to try to interview for that, because if they're not coachable, I'm not interested.
We talked at this table about, in some program outcome documents that I've seen, it's listed as like the ability to take, receive, and act on criticism or critique. Like, how do you take it, and then what do you do? Who was I talking to just yesterday about the ability to just sort of stand there and listen? It was you. As you give them feedback, they just start talking at you, like, and they won't stop talking, and you're like, just stop. I just need you to listen. Right? I just need you to hear what I'm telling you. Yeah. And then you get into that. Like, why do you have to make it suddenly about, can you not know your place and just shut up because I'm your boss? I don't want it to be that thing, but sometimes it's like you have to just listen.
I will turn this scene shop around.
Don't make me pull this play over. How about this table over here?
Okay. So ours was demonstration of troubleshooting process and documentation. So there's kind of two levels. If this were for a project level, we were thinking of a rubric that you could like list out the different parts of the process. Like, did you iterate? I don't care how good it was. Did you do it a couple times? And just getting into the like breaking down the steps and making sure they're hitting all of them, just so it becomes muscle memory and that you can track along the way. But also at the portfolio level, like as somebody that hires, how do I know that you guys are actually delivering on that outcome? And I was thinking of like on the portfolio level, having a little 2-minute video on, oh no, I ran into this thing on my project. Here's me troubleshooting the circuit and talking out loud about the things that I'm thinking about. And then you're able to see an output of how that person thinks. And you can't always get that out of an interview. Like you'll get the best version of the story out of the interview, but I'd like to see you actually going through the process.
Interesting. So in your mind, similar to the question we asked over here, I think, is that summative moment of the ability to be capable at, I don't remember what the phrasing was.
Yeah, we did applying and capable.
Applying troubleshooting skills for circuitry. Is that a summative event at the end of the 4th year? Is it a thing that is happening over time that's being assessed? Right? Do I do like a big old setup where I've got a whole bunch of sound equipment in the room like you guys were talking about, and on your last day of class, on the last day of the semester, you've got to run around and fix everything? Is that what you're talking about, or is it something else?
I think it's good to see improvement along the way. Yeah, because I always think of like our post-mortem process for projects, being able to look back on the project and say like, hey, what would I have done differently? So having that along the way is good. But as an employer, I don't know how much of that I'm going to be able to get from your portfolio. So still being able to have an example, you almost need like the long version that you as a person can narratively express in your interview, but then also the short version that someone can see scanning your, maybe not resume, but if they do look at your portfolio. So
Sure.
you gotta be able to tell the story in an elevator and also in an interview setting.
Sure. And the portfolio is another piece of signature pedagogy that is pretty specific to the arts. that engineers don't have. And then I don't mean to keep picking on you, but you were a student in the program. Like that was a whole new world for you guys, right? Standing up there and getting that feedback and generating that document over and over again. It's not something that was happening in the engineering classes. So that's another collision. Like how do you get engineering students comfortable with that? We've got time for one more go around. We've talked about the skills. We've talked about sort of how, at what levels. We've talked about how we assess it at the end. How do we get them to learn it? Take a few minutes and osmosis. 3 to 5 learning activities.
Graduation's in 15 minutes. The sound system doesn't work by then, you don't graduate.
That's one, right? Like what are the learning activities in which they learn? Is it you hand them the textbook or the manual for the thing and say, go to town? Is there something that you have to do with them to help scaffold them through it? How do you get them from novice to capable?
Are we a professional training program? Or are we, where are students going?
This is in school, 4 years.
But where are students going though? Because my graduate school is a professional training.
So we're talking undergrad, combined engineering, entertainment, engineering, theater program. So it's probably going to be a BSE or a BA, but it wouldn't be like a BFA arts program. Yeah. Beyond that, make your own decisions about what that means. All right, we're close to time for the day. So everybody got a couple of things to talk about? Yeah? Where are the microphones at? You guys are here. We'll start with you guys. A couple of, like 2, maybe 3 learning activities.
Okay, here's some learning activities. We would want, in order to reinforce understanding, we would want the students to be able to understand the design proposed by the scenic designer. And so the proposed assignment there is to take a designer's sketch and translate into technical drawings. Another one here is to apply existing information about best practices and the current state of the art to demonstrate and justify safe construction methods. I think this relies strongly on classroom instruction, and the evaluation method would be to see if the drawings that they submitted adhere to the best practices described in class.
Awesome. That's the first reference I've heard to codes and statutes embedded in the thing. Very good. Very good. Very good, because we were talking yesterday even about sort of the remembering level of that. Yeah. Microphone's back there. You guys.
Okay, so we were talking about the application of troubleshooting process and documentation. So they need to know what that process is that they're going to try and follow. And we're kind of bouncing around several ideas. One is like beginning of the semester, and maybe this is a sound class, for example, where you might have to troubleshoot equipment. What do you guys think like the troubleshooting process looks like, and guiding the conversation towards a process everyone can agree on, and then they're they have some agency in creating that process that they're then going to follow. So that could be one. We also had the idea of leading them through the process without like explaining the psychology of it and being like, why did we do all of this? And then going so that they have a way to visualize what the process is used for rather than going through a PowerPoint presentation first. So we were bouncing on a couple things there. And then like, how would you practice that? It would be students walk out of the room, teacher breaks things, and then come in, fix it, make it go.
Work with these guys.
Yeah. Exactly. So, but we bounced around having peer feedback opportunity with that. Like if you're watching a group of students put something together, if you see something as like, hey, we haven't, like, we're going down this rabbit hole, we haven't iterated our idea in a while. Having like someone that's not actively putting their hands on things say, hey, maybe we should think about this, and giving the students the opportunity to give feedback to their classmates.
There's an interesting thing in that last bit you said about sort of mixed experience cohorts. And I know that there are some people in here who do martial arts. I don't, so I may say some things that are wrong, but from some of the instructional design research I've read is you're often with people at various different levels of expertise and in the same room at the same time. And there's opportunity to learn by watching and to learn better what you're doing by providing examples, right? And so having students who are advanced proficient in the room while you have students who are novice and capable to provide that feedback. Now you're giving learning opportunities to multiple students and assessment opportunities to multiple students, right? Yeah, okay. Where's the microphone here? Yeah.
So we talked about taking team collaboration from, the introductory level, low stakes group project in class, right? And maybe where you're not doing the role that you think is going to eventually be your career path. So you may be in a classroom full of engineers interested in this, but someone has to act as the scenic designer and somebody maybe has to act as the director and play out the scenario and, have group projects where you do that. And that the faculty member is probably a little more heavy-handed in mediating the group through the process because we don't know how to do that yet. And sort of working your way up through the 4 years of, do you have then a scaled, in one of your more advanced classes, still group collaboration, still problem solving. Maybe you're problem solving a single scenic element that you're trying to discover. And now you're a team of engineers trying to figure that out. And maybe the faculty member is asking questions that might guide you along the path, but not necessarily mediating the conversation up until, your final project that may be something fully realized. And hopefully you're just being nudged along for good communication and problem solving. And the final point, one of the things we talked about, Jennifer asked, how much do you ask the students to either peer evaluate or self-evaluate? And we think that's a key part of that. And one of the things that we do, and I say we, not me, because we don't need the power dynamic of me being in the room for this, but our design faculty with a production team kind of hosts them through their own self-assessment of working with each other as a design team, the student collaborators, that honestly, and they do it in front of their design student peers. That's a classroom of just the design students hearing what worked well in the project and hearing what didn't from their own peers. And I think there is, particularly, again, talking about what this age group of students is bringing to the table, the self-analysis is mentoring them through that is also helpful.
Absolutely. There's a whole metacognitive skill called calibration or monitoring. How many of y'all familiar with this? It's how well do you know what you think you know, right? Dunning-Kruger effect, maybe y'all have heard that, right? Like it's really easy for a novice to think they know stuff that they don't know. And there's some researchers who posit that really what you're doing when you learn isn't learning stuff, but learning how much you don't know so you can find out the stuff on your own, right? And so that is part of that self-reflective process is, did I do this well or not? I don't know. I need to look at it and activating that cyclical process. Yeah.
And what you see with the peers is often, I am happy to say what Jennifer did really well. And I can't see that in myself because I'm thinking about the 84 failures that I made in my process. And so it's a good in general, unless something was a complete disaster. It's generally a really good feedback and progress kind of milestone.
Yeah, absolutely. I love that. That's great. Over here, you guys. Nope.
Let's see. So we talked about how to kind of teach the data networking thing, and the hose idea I think was really good because really it's kind of just teaching how signal gets from point A to point B, and sometimes it's very opaque, digital systems because you can't see things going on. So the idea of the water and the hose is kind of a first level thing of the data needs to flow from here and through here and to here and to here. So that might start out with it. 100 level data networking concepts, just what is a switch, what is a hub, what kind of cable, what is an Ethernet cable, how does it plug in between things, how to terminate one. That should be pretty easy. If you can solder, you should be able to. And then after that, then get into the configuration part where you have to have a computer to see what's happening inside there and showing the tools of how to do it. Now, nowadays it's really easy because everyone has made network switches that you can just say, I'm a lighting port, I'm a sound port,
Mhm.
I'm a video port,
Mhm.
and it helps a lot. But you can still get under the hood and see
Sure.
what it is that's happening in there. So that would probably be the way to go from I've never heard of a network in my life to a real basic level of
Sure.
understanding, and then from there deciding, knowing a lot about which systems are plugged in. So maybe automation, lighting, sound, video, and deciding which one can kill someone. That one needs to be the highest priority, and how do we set that priority so that
Mhm.
when you press the e-stop, and if it, God forbid, was the network connection e-stop, that data actually gets through first, no matter what,
Right.
no matter how many sound things are happening or video feeds are jamming down that line. That always goes first, you know,
Sure.
if you're converging networks.
Yeah.
So kind of an understanding of that topology of what's most important, what's least important.
Sure.
You know, lighting can get there a lot later because it doesn't go very fast, right? We're
Sure.
still running DMX through the network, right? So kind of that level of understanding,
Yeah.
I think would be the high points. Did we miss anything there? Yeah.
What I love about that is it has gotten far more specific than just a cascading set of failures that you have to fix, right? Because now we're talking about priority levels and VLANs and all that stuff, which is,
Now that's level 2.
sorry. Sorry, you're right. You're right. Sorry. So that's fantastic. Thank you. That's great. So just to sort of wrap us up, because I know we're all ready for dinner, there's a couple of pieces here that I hope that you all take away, but I'm going to tell you first what was most important for me that we take away. We're having lots of people ask this question, like, what do students need to learn in these disciplines? And so I'm hoping that if you've got written down notes, you can send me photographs of those so that we can start to compile this, because we want the Fusion Studio to be a place where we can disseminate some of this information to folks and say, this is what we're collectively finding from our either academic partners and our industry partners. This is what you need. If you're going to come out with this, this is what you need. Second, we're hoping to build some out of this group and others, some working groups to continue to develop that, to continue to develop how we integrate codes and standards, to continue to develop things from a conversation this afternoon about research and innovation. If you're interested in being part of those conversations, use the feedback form there. But most importantly, I hope that for at least some of you, the exercises today are things that you could take back to your academic institutions, certainly as practices for how to think about how to integrate these things into your programs. Because one of the things that I certainly am recognizing more and more is I only have 13 classes, right? The thing we said before. I have 40 credit hours to try to cram all of this in. And all that you described to get to even capable, that could be 5 classes. And how do I fit that in with everything else, right? And so that is some of the next levels of conversations that some of you are going to have back at your schools that we also have to have here more broadly is how much is too much to squeeze into 40 credit hours. Anyway, this has been a fantastic day and a half. You guys are just great. And it's so great to have this much brain power and this much community in the room. Thank you all for being here. I hope you've had a great time. And y'all know where East End Grill is, I hope, if you're going to dinner tonight, and we'll see you all over there.
Who did these go to?
Yeah, where do we? I'll leave them on the table.
Okay.
Oh, Rachel said. Awesome. Thanks again, everybody. Thank you all very much.